So let's dive into the Copilot stack. So Satya already showed this, and we're going to blow it up a little bit now. So this is how our Copilots at Microsoft are structured, and these are some of the things that we're going to be diving into greater detail in subsequent talks for you all to have a look at, to pick up, to use, to learn about, and to make things. Some of this may look familiar. So there are 3 boxes. You can think of these as roughly corresponding to the 3 tiers of a normal application. So you've got a front end, you've got a mid-tier, you've got a back end. So the front end, the things that we've already talked about, is you start with understanding what your amazing product idea is. The thing that's a little bit different about the user experience design with Copilots is we have more or less been building user experiences the same way for 180 plus years since Ada Lovelace wrote the first program. We have had to understand what the machine is capable of, and then we are fiddling around with how we express the connection between the human and the machine, in very explicit ways. So what that means for you all is fiddling around with user interface elements, menus, binding code to actions, trying to fully anticipate the needs of the user and architecting your applications in a particular and familiar way so that people know how to get at all the functionality, the capability that you really built into your code. The thing that's a little bit different in a Copilot is you're going to spend less time thinking about what your user interface widgets are and trying to second guess the user about what it is they want, because they have this really natural mechanism to express what it is they want, natural language. And so what you have to think about in the design of these Copilots is what it is you want the Copilot to actually be capable of. So what are the things the model can't do that you need to augment with a bunch of the stuff that I'm about to show you in the orchestration layer with plugins and maybe even with fine-tuning models or using a portfolio of models to accomplish. But it's going to be way less of that fiddling around mapping user interface elements to little chunks of code than you're accustomed to. And you also, on the flip side of that, have to think about what you want the Copilot not to do. And so this is important in how you're thinking about safety, but also because the thing at the bottom of the stack, these foundation models are sort of a big bucket of unrestrained capability. You're the one who oftentimes has to restrain it to your particular domain. For instance, with GitHub Copilot, a bunch of the work that we did is to keep the model on task, which is helping you solve your development problems. You're not trying to figure out what the best menu item is on Taco Bell when you're sitting in GitHub Copilot trying to write a piece of code. So that's the user interface, just broad brush, what is different there. So now let's talk about orchestration. So orchestration is the business logic of your Copilot. And as I mentioned, when we started building our own Copilots, every team inside of the company was building their own orchestration layer. So all of that logic to figure out how to get a thing to sequence through all of the models, do all of the filtering, do all of the prompt augmentation that you have to do to build a really great app. And we just sort of noticed that there was commonality across all of those things. So one of the things that we did that greatly affected our ability to get these Copilots out to market at scale and to do more ambitious things was to decide that inside of Microsoft, we are going to have one orchestration mechanism that we will use to help build our apps. That is called Semantic Kernel, which we've open sourced, and there's a session on Semantic Kernel later at Build, which I would encourage you all to attend. But we also know that we're not the only ones who've seen that there's all of this commonality across orchestration. And there's some really great open source orchestration tools that work super well inside of the Azure ecosystem that we're building. So Harrison from LangChain, shout out to Harrison, is here with us in the front row. Yeah, give Harrison a round of applause, please. So LangChain is one of the most popular open source orchestration mechanisms, and Harrison, with a very small team, has built a thing that is useful to an extraordinary number of developers. So, and orchestration isn't a solved problem. We're going to see a lot of new ideas there, and the thing that I want to assure everyone here in the room is that you'll be able to use whatever orchestration mechanism you want. Like we'll give you some options that we think are great for us, like we'll point you to some of our open source favorites, but if you want to roll your own thing, like that's your choice. Like I'm a developer, I like rolling my own stuff sometimes too. One of the things that you'll see in Scott Guthrie's talk that's coming up next is prompt flow, which is another orchestration mechanism that actually unifies LangChain and semantic kernel. And so like I encourage you all to go dive a little bit deeper there. So inside of the orchestration layer, the fundamental thing that you're going to be manipulating is a prompt. And so a prompt is just a bucket of tokens that is generated by the user experience layer of your application. It could be, you know, in something like Bing Chat or ChatGPT, like a question or like a thing that a user is asking the model to do. Or it could be something that your application constructs, like where it's not a direct natural language thing from the user, but a natural language thing that you are conveying to the model from your application. And a big part of handling those prompts at the beginning stages of orchestration is prompt and response filtering. So basically saying, I'm not going to allow these prompts through because maybe they will cause the model to respond in a way that doesn't meet the needs of your application or do something unsafe. And you also filter responses on the way back up. So after the model has produced a response to the prompt, like you may decide that you want to filter some or all of the prompt out. Like a natural thing to, where this happens is with the safety infrastructure that you're going to see Sarah Bird talk about in her talk later. But like there are other reasons that you may want to do some filtering on the responses. You also have this unit of prompt code called the meta prompt. And the meta prompt is the standing set of instructions that you give to your copilot that get passed down to the model on every turn of conversation that tells it how to accommodate itself to the copilot that you're trying to build. It's where a bunch of your safety tuning is going to happen. It's where you sort of tell the model like what personality you want it to have. So like for instance, we use the meta prompt to do things like telling Bing Chat to be more balanced versus more precise. It is also like how you sort of teach the model new capabilities. So like you can even think of meta prompt design as a form of fine-tuning. And so it's just far easier to do things in the meta prompt than to like have to go down to the lower layers of the infrastructure and start rolling your own things. Once you get past the meta prompt and the prompt filtering stages, like you start to think about grounding. And grounding is all about adding additional context to the prompt that may be useful for helping the model respond to the prompt that's flowing down. So in the case of Bing Chat, which I think is the first place that was really doing retrieval augmented generation before retrieval augmented generation had a name, we basically look at the prompt, the user query, and issue a query to the search index to find relevant documents for the prompt. We add those documents to the prompt and send it to the model so that it has that extra context to provide a good answer. Increasingly, people are using vector databases to do retrieval augmented generation. So like you may take the prompt, compute a set of embeddings for them, and then do a lookup in a vector database that is indexed by those embeddings to get relevant documents for the prompt and give that extra context for the model to give you a better answer. But you may also augment the prompt and do grounding with arbitrary web APIs, and like you can even think about using plugins for doing grounding. And so the next step here is like this is where plugin execution happens. So at this stage, like again, what I just mentioned in grounding, like you may use the plugin to add some extra context to the prompt before it goes down to the model, or you may execute something, do a plugin execution on the way back up from the model so that you can take an action on a system. So once you get through like all of the stuff in the orchestration layer, and I should say like also, you maybe do multiple turns through this whole system. So like calling multiple models, like making multiple passes through this whole pipeline in order to like get what you need from the system. But at the very bottom of the stack are foundation models and infrastructure. And we give you a bunch of choices for how to use foundation models in this Copilot platform on Azure and on Windows. So you can choose to use one of the hosted foundation models like the ChatGPT model or the GPT-4 model that are now available on the Azure OpenAI API service. You can fine-tune one of these hosted foundation models. The ChatGPT 3.5 fine-tuning APIs are live now, and you'll be able to fine-tune GPT-4 soon. But if neither of those options work for you, like you have sort of exhausted all of the things that you can do in the orchestration layer to get your Copilot to do what you need, and neither of these things will work for you, like you can't wholly solve your problem with a hosted API because of whatever reason, you can't use the fine-tuning APIs to accomplish what you want to accomplish, you can bring your own model. And like we are incredibly excited about what's happening in the open source community right now. Like there's a bunch of brilliant work happening with open source models. And one of the things that you will see in the next talk is we have the Azure AI catalog, model catalog, that is going to be a place you can go inside of Azure to find the most popular models on Hugging Face and in GitHub, where you'll be able to push button, provision, and deploy those models to Azure to use in your Copilots. And also, like, you can train your own model from scratch. Like, as we mentioned several times, like from the most ambitious models in the world, the ones that OpenAI are training, all the way down to like smaller things, like Azure AI supercomputing infrastructure and our environment give you a great way to train your model from scratch if that's what you need to do. So this is the Copilot stack, top to bottom.